Yeah. Yes. So is that correct? Good. Okay. Now, my condition is that I want to choose a single n. Here I'm having n1. Here I'm having n2. I'm having two n1 and n2. I want to choose a single n which should work for both of them. If you are present in my last lecture, then you must answer this. I'm asking with everyone. I want to choose a single n which should work for both of this. For this also, for this also. Perfect. Very nice. The one which is maximum. So I'll choose n not as maximum of n1 and n2. Correct? Once I choose the maximum one, what is the condition I'm having? I'm having the condition En minus L that is less than epsilon for all n greater than equal to n naught now I am having, correct? Earlier I was having n1 here. Yes. Can I solve it little bit? Do you know the property of mod? How can I break this mod? Any what? हम्म पक्का? हाँ हाँ वही वही बट तूने शायद एक रॉन्ग बोला तूने स्टार्ट वाला. वन ये नहीं वन नहीं है भाई ये एल है. ठीक है ओके डोंट गो दैट मच फास्ट आई जस्ट वांट टू ब्रेक दिस तो ब्रेक करने का क्या समथिंग इज लेस देन एप्सिलॉन दैट मीन्स व्हाट माइनस एप्सिलॉन इज लेस देन en minus l that is less than epsilon. Do you agree? Do you remember this thing? Mod x is less than k होता तो minus k is less than x. इतना ठीक है क्या? What next? Minus l को दोनों साइड भेजा तो you will be having what? L minus epsilon is less than en and that is less than L plus epsilon. Do you agree? For all n greater than equal to n naught. This is I am having. I'll put it as a equation 1. And also I am having same thing for Cn also. That is mod of Cn minus L that is less than epsilon for all n greater than equal to n naught. Can I do the same thing again? Let us break the mod Cn minus L. Why am I breaking the mod? Can somebody think of that? Because till now I have not used something which is given in my question. I have not used that. So I wanted to use, that's why I need somebody to be away. Yeah. This is L minus epsilon. This is L plus epsilon for all n greater than equal to n naught. Why am I breaking? Why am I making an and cn separate? Do you see I have not used something? I have not used this. Do you agree? I want to use this thing. To use to use this, I need en and cn separate. So that is what I am having. Now from this is 2 and we are having en is less than equal to bn is less than equal to cn, correct? This is what I am having. Can I write the lower limit of an? What is lower limit of an? Can I write it? That is L minus epsilon that is less than an and that is less than equal to bn and that is less than equal to cn. And can I write upper limit of this? Do you agree? Oh, this is sorry less. And this is true only if for all n greater than equal to n naught. Then only this is true. Okay, forget about en and cn. Now can I write my bn is lying between them? L minus epsilon and L plus epsilon. Do you agree? What next? Can somebody tell me what should I do next? परफेक्ट, वेरी नाइस। मतलब पहले जैसा हो जाएगा ये बी एन माइनस एल दैट इज लेस देन एप्सिलॉन फॉर ऑल एन ग्रेटर देन इक्वल टू एन नॉट। what does this mean? This means limit n tending to perfect, and limit this is equal to L, hence proved. Do you agree? Just go back to the proof. Go back to the proof once again. The main part is choose a single n which should work for both the thing. So how did you decide that? That should be maximum one. And I have shown you by the graph. If I go back, I'll show you once again. Yeah, do you see that? Here it was n1, n2. If I choose n1, then there will be some problem. There will be some people which are remaining. If I choose n2, everybody will be in the epsilon band. So maximum should work. Correct. Nice. So this was your sandwich theorem. Now sandwich theorem is very important in solving the limit. Uh, Let me just tell you one of the famous one. Mm, yeah, limit n tending to infinity sin x upon x. How will you solve this? First of all, does anyone? How will you solve this? If I want to solve the limit that is n tending to infinity, what I wanted everybody should be in the denominator, then only I can put at 0, correct? But in the numerator I am having sin x. So what should I do? And I cannot use that L'Hopital rule also. What is L'Hopital rule? If something is 0 by 0 or infinity by, are you aware of that? Yeah, I'll talk about later. Maybe you must have एल हॉस्पिटल भी बोलते शायद बहुत लोग उसको लापितल, that is the correct pronunciation of that. So hmm, yeah, so can I use it here? Sin infinity, it is infinity, correct? Can I use L'Hopital rule here? Yeah, I'll just repeat it. Once you want to find limit something extending to e f of x upon g of x, correct? And if the function, if you put x tending to a, that is if you put it here and here, if it is either 0 by 0 form or infinity by infinity form, that means if you put the value of e here, then this is becoming 0 and this is also becoming 0, then this is 0 by 0 form, or this is infinity, this is also infinity, then this is infinity by infinity form. Then what you should do, you should take the derivative, then the limit value will be limit extending to e f dash of x upon g dash of x. This is the rule. I hope you remember. If I gave you some, if I'm sorry, limit extending to e x minus e raised to n upon x minus, oh sorry, x raised to n minus e raised to n upon x minus e. Do you see? If I put e here in the numerator, it is giving me 0. If I put e here in the denominator, it is also giving me 0. So it is 0 by 0 form. So once you are having 0 by 0 form or infinity by infinity form, then you can take the derivative. So our value will be limit extending to a, take the derivative, derivatively n x raised to n minus 1. Constant is 0 and in the denominator you are having 1. So what is the answer? N e raised to n minus 1. Do you remember? This was the formula you were asked to recall that thing. Yeah. Now my question is, can I use L'Hopital rule here? Or any limit technique? कैन आई यूज लापितल बिकॉज लापितल इज द मोस्ट फेमस वन बिकॉज जो भी तुम लोग ने लिमिट के फॉर्मुलेस किए हैं एवरीथिंग यू कैन गेट इट फ्रॉम द लापितल रूल. My question is, can I use L'Hopital rule here? That is my question. So, what should you ask? Where does your numerator and denominator goes? What about numerator sin x? And what about denominator? Denominator, that is, you are sure that denominator goes to infinity, correct? What about numerator? Perfect, very nice. That is what I wanted. Sin x will never go to infinity, correct? Many of the people used to write कि हाँ ये sin infinity हो गया. They will not think anything. They will say sin infinity तो infinity होता है. But that is not true. Sin is always lying between -1 and 1. It will never go to infinity, correct? So you cannot apply L'Hopital rule here. Do you agree? I have seen many of the people doing this mistake, so you make sure. So actually, you gave me the answer. That is, you gave me sin x is always lying between. Oh, sorry. It is n, huh? As I'm putting n tending to infinity. So there is no issue. My n and x look same, so I don't have trouble. Now you told me that sin n is lying between -1 and 1. But I wanted to find this limit, sin n upon n. What should I do? What should I do? Should I divide by n? Correct. And n is a positive number. There will no sign change. Do you agree? Okay. What else? Have I proved something? Can I apply that sandwich theorem here? Sin n by n is squeezed between two sequences where both the sequence converge to something. What about 1 by n? 1 by n converge to 0 and -1 by n. Forget about minus. Take minus outside. 1 by n. Again that is 0. So 0 into. So both the guy. This is also converging to 0. This is also converging to 0. So what is your conclusion? By sandwich theorem, you can say this limit will also go to 0. Do you agree? So answer is 0. Do you agree? Do you have any doubt here? Tell me. Yeah, nice. Okay, let me ask you one more problem. Mm, Say En is equal to 1 upon n plus 1 the whole square plus 1 upon n plus 2 the whole square plus 1 upon n plus n the whole square. I'll come this type of sequence in your semester 2 also. We'll see. But now let us see. I want to check whether it is convergent or divergent. Can you tell me something whether it is convergent or divergent? And where does this converge to? If it is convergent, then where does this converge to? Yeah, it converges to 0. Yes, why? Why do you have any answer for this? This conversion. न्यूमरेटर तो है ही नहीं इधर. अगर देखो हर एक स्टेप में तो in the first term if you see it is 1 and it is n ka term, and if you take limit n tending to infinity an, so each of the term goes to 0. Do you agree? Hmm. So that is quite clear कि हाँ डायरेक्ट ही दिख रहा है वो 0. But still if you want to prove this then you should do it by sandwich theorem. What should you do? Let me just give you a hint. You should start with, since n is less than equal to n plus 1, that is less than equal to n plus n. Do you agree? Do you agree with this expression? N is less than equal to n plus n, n plus 1, and that is less than equal to n plus n. So if I take, because I wanted square in that term, so now I can say n square that is less than equal to n plus 1 the whole square, that is less than equal to n plus n the whole square. Can I say like this? Yes. And what I want 1 upon, no? So if I take 1 upon n square, that is less than equal to, no, that inequality will change, no? Correct. Greater than equal to 1 upon n plus 1 the whole square, and that is greater than equal to 1 upon n plus n the whole square. Okay. Now, whatever I did at the place of n plus 1, at the place of 1, can I put 2 here also? Then also this inequality will be same. Can I do that? If I put 3 also, then also the same thing. If I put 4, 5, 6, correct? That means I can write similarly 1 upon n square is greater than equal to 1 upon n plus 2 the whole square. That is greater than equal to 1 upon n plus n the whole square. Correct? And so on. 1 upon n is greater than equal to 1 upon n plus 2, n plus 3, n plus 4, correct? And the last term will be n plus n. Or n plus k if you want, up to k, then you can take. But I just want to write the last one. So it will be 1 upon n plus n the whole square. Yes, that is greater than equal to 1 upon, actually that is equal to this guy, so I don't have to be worried. N plus n the whole square. Do you see what is your question? It is the addition of these people. Yes. Sorry, this is n square. Huh? Correct? Do you agree with me? And how many terms are there? 1, 2, up to n. So if you add all of them, then what will you have? In between you will be having your an, correct? In between you will be having your an. And what is your lower bound and upper bound? Can you tell me? This will be 1 all the time, 1 upon n square, 1 upon n square. And how many terms? N terms. So this will be n into 1 upon n square. And what about this? It will be n upon n into 1 upon n plus n the whole square. And what is this? This is 1 upon n greater than equal to an, and this is 1 upon 2n the whole square. Then 2 2 will become 4 and 4n, correct? And what can you say about this? This is also going to 0. This is also going to 0. So by sandwich theorem, can I say something? an will also go to 0. Goes to 0 matlab limit n tending to infinity en that is equal to 0. Is that clear to you? Is this, is the solution clear? Think about it. Tell me. Okay, good. Let us see one similar type of question. Now I'll ask with you. Give me a expression. Suppose en is 1 upon root of n square plus 1 plus 1 upon root of n square plus 2 plus 1 upon root of n square plus n. Now, what is your observation? What do you think? Where does this converge to? Where will this guy converge to? What is your observation? What do you think? 0? Everybody, do you agree? Yeah. And you will be surprised to see that this does not converge to zero. That's why I just want to. That's why I choose this example. Mm. Yes, yes, exactly. This converges to one, and we'll prove that with the sandwich theorem. Exactly. So you cannot say when you are having an equal to something like that, you cannot say that each of them converges to zero and something like that. Correct? Whatever we did in the earlier case, you cannot do that. बोलो. हाँ वैल्यू मतलब कितना वैल्यू पुट करेगा तो. अरे भाई जीरो थोड़ी पुट कर सकता है तो. Your n is starting from 1. So you should start with पहले a1 निकालो. a1 will have only one term, that is 1 upon root of 1 square plus 1. a2 will be having two term, that is 1 upon square root of 2 square plus 1 plus 1 upon square root of 2 square plus 2. समझ रहे हैं? फिर e3 and like how you can see कि where does this goes, कहाँ पे जा रहा है ये, कहाँ पे जा रहा है ऐसा, you can see like that. That is what you can do, but that do you think ये मतलब ये कर पाओगे? You have to do so many calculation here. Do you see? See here n, then you are having n terms. If I talk about even, it will have one term, a2 two terms like that. Well, I'll just erase this and let us do that. Let us try to see by sandwich theorem. Can you give me a expression like in the previous one, which we used, so that en will be in between? That means your 1 upon n square plus 1 n square plus, so you should start with n square plus 1. Can you give me a lower bound for n square plus 1 and upper bound for, what should you choose? You should be quick in this. Okay, upper bound n square plus n. Very nice, good, correct. And how do you observe that? N square plus n you will see here, and lower bound it was quite clear, that is n square plus 1, तो इससे एक छोटा तो n square ही रहेगा. Yes. So what about I wanted square root now. If I take square root everywhere, can I take square root first of all? I can only take square root if all the numbers are positive here, and that is quite clear, correct? So I can take square root. So it will be n square, and this will be square root of n square plus 1, and this is less than equal to n square plus n. What else? What should I do now? 1 upon, this will be n, no? This is same as n. So it will be 1 upon n, that will be greater than equal to 1 upon n square plus 1, and that should be greater than equal to 1 upon root of n square plus n. Is that clear? Okay. And 1 is not a special number. At the place of 1, I can put 2, 3, 4. Correct? I can write similarly 1 by n is greater than equal to 1 upon root of n square plus 2. That is greater than equal to 1 upon root of. Do you see the answer now? Last term, what do I want? N square plus n. That is actually equal. What shall I write? N square plus. Correct? Now, what I am going to do next? Yes, add all this thing. If we add all this thing, then in the mid you'll be having your an. Can you tell me what is this and what is this? It will be 1 by n, 1 by n, how many times? N times. So it will be n into 1 by n. What about this? N times 1 upon square root of n square plus n. Okay, so this is 1, that is greater than equal to an, that is greater than equal to n upon square root of n square plus n. So you already know this converges to 1, but what about this? तो पहले इसको सॉल्व करना पड़ेगा ना. Let us see, limit n tending to infinity n upon square root of n square plus n. How will you solve this? Yes, how will you solve this? Very nice. Divide numerator and denominator by n. If you divide numerator, you will be having, this is n, you will be having 1, and if you divide n और n को स्क्वायर रूट में डाला तो कैसा आएगा वो? It will be n square plus n